Now let us discuss about rigid body. So what do we understand by the term rigid body? A rigid body is an idealization of a body that does not deform or change shape. Correct? So what do we understand by this particular definition? A body which does not deform or which does not change its original shape is termed as rigid body. Formally, it is defined as collection of particles with the property that it can have a proper distance between their particles. Collection of particles with the property that distance between each particle will remain uniform and it will remain unchanged during course of motion, right? So this is what a rigid body is termed as. Now simply if we consider rigid body, that means whether rigid body is at rest or it is at motion, it should not change its original shape. In the study of special relativity, a perfect rigid body does not exist. The object can only be assumed to be rigid if they are not moving near the speed of light. So basically a rigid body system of mass points subject to holonomic constraint that the distance between pairs of points will remain same or constant. So simply if we want to understand that what is actually the rigid body is, then any such body which does not lose or change its original shape, whether it is at rest position or it is in the moving position, then it is termed as rigid body. So here you can see we are having three different blocks. Block number 1, block number 2 and block number 3. So in the first block, if you will start applying forces from all the direction, or if you start applying pressure from all the direction, then it is going to break. So if the given block is going to break, then this is not a rigid body. It should sustain its original shape, then and then only we can call it as a rigid body. The next block is this one. So if you will see here, actually it was a rectangular block like this, but when you started applying force or pressure from all the directions, it has changed its shape. Now it is in the position of arc like this, right? So when an object is changing its position or changing its shape, then it is not a rigid body. And the third example you can see here, even though we are applying same amount of force or pressure from all the directions to this block, the shape of the block remains intact. And whenever the shape remains intact, that means that body is a rigid body, right? So a rigid body does not deform under load, right? Whenever we are supplying any kind of load, force or pressure, it should sustain in its original shape, then and then only it is termed as rigid body. So let's go to the next point where we are going to compare a particle versus rigid body. In the last lecture, if you recall, we have seen what is particle, right? We have covered space, time and particle. So if we recall what particle is, then we will be able to understand rigid body more clearly. Now let us see why we are calling it like this. Here we are going to compare a particle versus a rigid body. So what is a particle? A particle is basically a small constituent, right? A particle size and shape is not at all important. It can have any size, it can have any shape. But when we consider a rigid body, size and shape is foremost important, right? Size and shape is foremost important. Now, rigid body is made up of combination of various particles which are joined together or which have coupled together to form a rigid body. So basically a rigid body is a combination of various particles which are combined to form a proper shape. So when you compare particle versus rigid body, always remember that shape and size of particle is not important, whereas shape and size of rigid body is foremost important, right? So for a particle, size and shape is not important and it is treated just like a single point, whereas rigid body implies that body cannot be deformed. Correct? So this is how we can understand difference between a particle and a rigid body. Now, coming to rigid body mechanics. Rigid body mechanics may be understood in two different ways. One is static and another one is dynamic. So what do we mean by the word static? Static means something which is at rest, right? The word static means something which is at rest. So static deals with equilibrium of bodies under action of force, right? It is at equilibrium under all the forces which are applied. So if you will see, there are two pictures. One, a girl is sitting on the chair and another one is a crane which is lifting some load or lifting some container, right? So this girl is sitting on the chair. That means it is at static position. At this position, all the forces which are acting on the girls as well as on the chair are in equilibrium with each other, right? There is some gravitational force, there is some force of inertia and so on. So each and every force are cancelling each other and that's why it is in the rest position. The position of that particular body is not changing. So this is a static. Here also you can see that even though the crane is lifting the container here, but the container itself remains static. It is not going to change its shape, right? So this is a static. Next one is dynamic. So as you can see here in the given picture, or you can see a small video, you can see a moving car. Basically a moving car is an example of dynamic rigid body. So how we can say it is a dynamic rigid? Because it deals with motion of body, right? So car is moving, it is a dynamic function, and rigid body, that means even though car is moving, the shape and size of car remains intact. That's why we call it as a dynamic rigid body mechanics. So here you can see even though the car is moving, the shape and size of the car will remain as it is. There is no change in the size of car. It is not going to elongate or neither going to decrease in size, right? So this is our dynamic rigid mechanics. Now let us see some few fundamental concepts which are associated with introduction to physics. First one is length. So basically length